What you got? Number 5. Okay. You good back there, Joe?
Oh yeah, number 5.
Oh, you're reading my phone.
Yeah. What class is this? Good morning, yeah, but it says, good morning, everyone. I am in need of help with class. I cannot afford to drop it or fail it. And for my first time in grade, I'm failing. Wait, so that was in.
All right, so this one asks me for first derivative test, local extreme values. Y'all ready? What your answers graphically? What? Did you say what is that? First derivative test?
I could not.
So, and what's that find? What's first derivative find? Okay, but whenever you're
It finds the sign and elevation.
Okay, so the sign analysis, which tells us when the function is increasing, decreasing, which also tells us what? Where what occurs?
Where the maximum?
Maxes and mins. That's what I'm looking for. That's the purpose of first derivative here. Increasing, decreasing, maxes and mins. So for this one, it says identify the extrema. So I'm looking for maxes and mins. Before I start, does this have any domain restriction? Yes. Why? Okay, so I know that 8 minus x squared is got to stay greater than or equal to 0. Yes. Hey, Madison and Lainey. Have y'all heard from her? I don't know.
What is Stella's dying right now? Right? We hope you feel better. I hope you feel better. Yeah.
Yes, yes, yes. So -1 means that, so I flip that inequality sign.
Oh, that would be great.
Yeah. Yeah. Let's do this because y'all are clearly confused on this. Let's graph it and look at the domain initially. Well, because I wanted to see. Go ahead. Go ahead, Robert. Tell him.
I think, is it because it's under a radical?
Yes. Because if there's domain restrictions, right? If I'm restricted on my domain, first of all, I have to know if there's endpoints. Because if it's closed, I could have, then that EVT comes into play, right? I could have an absolute max on absolute min. If it's not closed, but there's restrictions, and I come up with a critical point being -2, but I can't go smaller than 0, then I have to realize that, wait, there's no graph there, so that can't be a critical point. Does that make sense? Yes, Miss Vanilla, that's perfect. Thank you.
But is that
You're the
giving
best
you
teacher.
like the range, or is that giving you like a point of interest, or what? Whatever it's called, the little. No, it is a point of interest.
Okay, so it's less than, but remember what happens when you take a square root. It's a plus or a minus, right? So here's what I got to think about. I got to think about, this is one of those funny ones whenever I end up in a situation like this. It's either going to be in the middle of these two or on either ends, and I have to decide which one it's going to be. So what you can do is you can look, well, if I picked, let's say I picked a real big negative point over here, really big, right? Maybe, I don't know, -100 even, right? And I plugged it in here. Am I going to get a positive or a negative under my radical? 8 minus -100 squared, right? I'm going to get a really big negative number, and I can't have a negative number under here. So I'm going to be in the middle. So I'm going to be between, so my domain on this one is going to be from -2 root 2 to 2 root 2, or -2 root 2 to 2 root 2. Okay? And now I did it that way. That's not, I've not done anything calculus. Right now I've just done algebra. I just found the domain of that function. Because whenever I find my extreme points, I need to make sure. This tells me that it's a closed domain, right? And because this is a continuous function on a closed domain, what does that tell me? There's an absolute max and an absolute min. So as I test, whenever I find this derivative, I'm also going to have to test these two endpoints. That's why that's important. So that brings back section 1 or 2 or whatever it was when we did that. All right, so now let's find the derivative. Derivative of what? Derivative of the first times the second plus the first times derivative of the second. So 1/2, 8 minus x squared times negative 2x. Negative 1/2. I have that there. Yep. I'm a little worried about these 2's here. Okay, so the 2's cancel. The x's do not because they're both on the top. So I've got the square root of 8 minus x squared minus x squared over the square root of 8 minus x squared. Everybody agree? Before I can find where that equals 0, what do I need to do? Multiply what? Common denominator. I got to combine them, right? So put this over 1. What's the common denominator? So I give it to both the top and the bottom here. This one's good, so I get 8 minus x squared over square root of 8 minus x squared. Everybody still okay? Look, this is the only calculus we've done so far. Everything else, algebra 2. 8 minus 2x squared over square root of 8 minus x squared. That's my derivative. All right, now remember my sign analysis. I've got some endpoints here. Negative 2 root 2, 2 root 2. Anything I find outside of those values, I do not need to include. And I'm going to test each one of these. All right. And I really don't have to do a sign analysis on this one because I'm going to have to plug into to find absolute, but I'll do it anyways. Top to 0 is going to give me stationary at rest. Yes? All right. So 8 minus 2x squared equals 0. Negative 2x squared equals negative 8. X squared equals 4. So x is plus or minus 2. Yes? Is that in my domain? Yeah. Negative 2 is bigger than when you multiply by square root of 2 and smaller than here when you multiply by square root of 2. Bottom to 0 is going to give me possible stationary but not at rest, right? And that just gives me what? Which is my endpoints here anyway. Right? So those are already on there. So since extreme value theorem comes in, I don't have to come in and do increasing, decreasing. They didn't ask me for increasing, decreasing. They just asked me for extreme. So I'm just going to test these points. So I'm going to need to find y of negative 2 root 2, y of negative 2, y of 2. Did y'all do this one right, by the way?
Definitely.
So you plug into the, to find, if you're testing the points, you're plugging into y. If you're doing a sign analysis, you're plugging into y prime. So it depends on which way you're doing it. If you're looking for increasing, decreasing, you're plugging into derivative. If you're looking for max, min, value, you plug into original function. All right, so original function, a, x times, let me write that here, so 8 minus x squared. So I got negative 2 root 2 times the square root of 8 minus negative 2 root 2 squared, which is negative 2 root 2 times the square root of 8 plus 8 or minus 8. Are y'all following me or am I just talking? Sometimes I just feel like I just talk. This is 0, so that's 0. Yes? Same thing's going to happen down here because it's positive, but because I'm squaring it, right? The negative and the positive are going to have the same value. So I really need to look at these two. These are the endpoints. So now if I do negative 2 times the square root of 8 minus 2 squared, that would be negative 2. 8 minus 4 is 4. And this is 2 times the square root of 8 minus 2 squared, which would be positive. What do we have? Absolute max of what? Of 4 at x equals 2, or at 2. And I have an absolute min of negative 4 at negative 2. All that's from the first derivative test. Ooh, that was a lot. Yeah. What else from your homework?
Maybe 12.
Got a camera on moose, so I have to keep checking. 12. Yeah. At my house. I got a camera on it, so I keep checking it. Yeah, I can hit talk and I can tell him stop. I pulled his bed right beside his couch, so he's not very good. We'll find out tomorrow what the test results were. He's still a little loopy from the anesthesia. They said big dogs are very sensitive to anesthesia. Like it took 3 of them to get him in my car. And then it was terrible to get him in the house. Well, he would try, and he'd try to stand up and his legs would just, wow, it was so sad. But, yeah. Best dog we've ever had, like, hands down, through my childhood, through everything, but he was the easiest to house, like, I mean, and he hates outside.
Dang. That's crazy.
Like, he will break my door down and get back inside. He's soft. He's always been soft. I'm telling y'all, he's more like a person than anything else I've ever seen in my life. Okay. Concavity test. So second, we're looking for concave up, concave down. So we're looking for second derivative. So first derivative, e to the x. Oh my goodness.
Well, I said none. I don't think it was.
All right, I'm definitely between 0 and 2 pi. None what? It asks you concave up, concave down. So when does this equal 0? It doesn't ever, right? If you think about the graph has an asymptote at 0. It never goes to 0. So it's always the same concavity. What is that concavity? Why? This is always positive. And so it's that. So it's concave up from 0 to 2 pi. Yeah. Yeah. On what? So you look at you know how we look at the first derivative. If it's positive, it's increasing. If it's negative, it's decreasing. For the concavity, we look at the second derivative equal to 0. Positive areas, it's concave up. Negative, it's concave down. So it's the same concept, exact same concept, but it's second derivative instead of first. What else? You ready to make it harder?
You want me to be honest?
I want you to lie.
Yeah, I'm ready.
No, don't lie. I was being sarcastic.
What? Don't lie.
Dun, dun, dun. Maybe that's why they say dun, dun, dun. Oh. Okay.
They're all bad.
See? I'm telling you, look up the conspiracy theory. You'll find it. That's what I'm saying. You have to read. It is creepy. And real bad turn. Okay. More second derivative test. Dum, dum, dum. What did she say? That was not where this was supposed to go. Not that. I never brought that up. Y'all went there.
But he's posted about Batman a lot before, like March 16th. March 16th.
What if Batman, like,
March 16th was the last
2020.
was the last time he was about Batman.
No, he's been posting about Batman since
he just wants to be happy.
Find all points of inflation.
I don't know how.
Find all points of inflation.
I'm not
Yeah,
gonna-
these are off your homework. I'm just doing one from each. The thing when we get to calculus is there's not always just a step by step. Like everything is so. I picked the hardest one though. This is the last one in the section, so I'll do the last one in the section to show you how to. No, there's different sections. Probably Tuesday or Wednesday. It won't be Monday. It won't be Thursday. What's Tuesday? What? Oh. All right, points of inflation, go.
How do you forgot? How do you do it?
I forgot how to do this.
Shut up.
There's gonna be more than one, right?
Yes. I changed mine. Y'all know I hate quotient rule. I changed mine to that. To find the derivatives. But you can do whatever you like, whatever floats your boat.
find second derivative?
This is what? Ew, this is terrible. Don't forget to chain.
I think I got the exit. Oh, oh. Forgot. Alright, Adam. Wow. I did so good too. I got the answer.
Are y'all with me? Am I doing it right so far? Have I made a mistake?
No, but I got it. But I'm
Jug or do our first derivatives match?
Nope, because I forgot to subtract.
How about our second derivatives? No? Let's see. Chain, at least your first part, does that match? Shut up, Stella. Shut up, Stella. Do the first. Second. First. Do the second with the chain.
You literally got this from us.
Number 20. Chain of this. What? What? Oh, minus. All right, let's see. Well, I distributed here. Distributed here. And then that's on its own. All right, so I got negative 6x cubed minus 4x squared minus 2x. You are right about that x equals 0. Did you get to this point? Take out a negative 2x. Leaves you with 3x squared plus 2x plus 1. And I can factor that. What multiplies to 6x squared? I mean to 3x squared. No, I can't. It definitely is because it happens at square root of 3, it says. It's a quadratic formula. When I find the zeros, all right, this bottom's never going to go to 0, do we agree? So we don't have any stationary points that are not at rest. Yes.
On top of all that,
Cubed. Sorry. No. Yeah. This. I'm fixing to work that on paper while y'all do this. This is 21. They're singing that song. Only it's supposed to cross. All right.
I cannot win.
Clearly, I can't teach today. So. Estimate. Use this graph and tell me everywhere where the first derivative is positive and negative, and tell me everywhere where the second derivative is positive. Using this graph. That's easy. Good.
The first derivative or second derivative?
To both. I want to know both. Tell me the signs of the first derivative and the second derivative based on this graph. Huh? No, you're just supposed to say where. So for the first derivative, where is it negative?
No, positive.
That's positive. That's okay. From -1 to 1, right? Because from here to here, the first derivative is negative, right? No? Okay. Where is it positive? Negative infinity to -1, u, 1 to infinity. And I'm fixing to tie this back into your second derivative test if you need just a second. All right, where, and I want to write it right beside it so you see. Where is the second derivative positive?
Positive. 0.
Yes. Why? That's where it's concave up, right? Where is the second derivative less than 0? Negative infinity to 0. Does everybody see how we're finding those points? Where's the point of inflection? 0, 0, right? This is where it's changing because it's symmetrical here. Tell me the points where the first derivative equals 0. -1 and 1. Where does the first derivative equal 0? -1 and 1. How do you know? Those are the maxes and the mins, right? That's what that means, okay? Tell me this. At these points, when x equals -1, is that a max or a min? Max. What's the sign of the second derivative? Dear Lord. What is the sign of the second derivative at that maximum? Sign of the second derivative at the maximum. Yes.
Whatever the.
Like positive or negative. It's negative because it's concave down, okay? So the second derivative is negative. And that gives me this is, in theory, this is like the second derivative test, really, okay? If the derivative equals 0 and the second derivative is negative, you have a max. Does it make sense? Why? When the derivative is 0, that's my possible maxes and mins. If I'm concave down, it must be a max, right? If the second derivative, that means if this is a min, what should my second derivative be? Positive or negative? Positive, right? Because if it's a minimum, it needs to be concave up. So it'd have to sit at the bottom of that concave part, so it'd have to be a minimum. So this is actually the second derivative test here, or a corollary to it, is that your maxes and mins, I'm going to come over here and write this for you because this is really important. Your maxes and mins occur when the derivative equals 0, and at that point, if the second derivative is positive, meaning if I'm concave up and my first derivative is 0, this is a minimum. So if they asked you on an FRQ, is this a max or a min? You could say, because the first derivative is 0 and the second derivative is positive, it's got to be a minimum. Okay? And if the second derivative is negative, then it must be, and it makes sense if you think about it. No, you would just say, because the second derivative is positive when the first derivative equals 0, this is a, yeah. And if you think about it, because this is concave up, this is concave down, it's got to be, it makes sense with it. Mathematically, it looks wonky, but it makes sense. Okay. What? Of course it is. I am.
Wait, Brian, what happened?
Let's apply that one time real quick, and then I'm going to be done. Because I know. And one of them we didn't even finish. Yes, Brian, we've already talked about this years ago. It was years ago. This time, I want you to use the second derivative test that I just showed you. Finding where the first derivative equals 0 and then testing the sign of the second derivative rather than a sign analysis to tell me where the maxes and mins are of this one. Don't graph it, no calculator, just by hand, just first derivative, second derivative, is a max. This is going to drive me absolutely bonkers. If I do it 2 more times and I get the same thing both other times I get it, then I'll say they're wrong and I'm right. I feel like I would have found that last year if I'm probably just doing something stupid and I'm continuing to do it because it's hard to catch your own mistake. That's why I told y'all to look at mine. Find all maxes and mins based on the sign of the second derivative, not on a sign analysis, but on the second derivative test. Remember, if the second derivative is concave up, is positive and concave up, then you found a minimum.
Oh, really? So,
right here. So find everywhere it equals 0 and then test the second derivative at that point.
Find where the second derivative is here and plug into the original.
No.
What?
Find everywhere. All right, look. Find everywhere the first derivative equals 0. Then look at those places on the second derivative and see if they're positive or negative. Like plug them in. I just showed it to you. I'm teaching you this way.
Wait, so plug in the first derivative into the second derivative. The x.
Yes.
Okay.
No. No.
What are you trying to do?
Plug it. Look. All right, we'll do this one together. 3x squared plus 6x. Yes? Where does that equal 0?
0.
Yes. Oh, I'm sorry. I thought she said plug back into the original. Now find the second derivative and plug these. I'm trying plug these points in, right? So what's the second derivative at 0? That's positive 6.
What do we get when we take this one? Okay, but what do we get when we take the second derivative and plug it into the first?
The sun. And then we look at the sun.
Because look at this, right? With the concavity. So what I can conclude here, I know this is a critical point, right? I don't know if it's a max or a min. Instead of doing a whole sign analysis, if I just find the second derivative, since this is an easy polynomial, and I plug that value in, I see that this is positive, which means I'm concave up. If I'm concave up and it's got to be a minimum, that tells me this is a minimum. I don't know about absolutes, but I just know local.
But why are we doing it this way when we do it the other way? Or like,
Bro, that's another way to do it. It's the second derivative test. It's a corollary of that.
but it gives you the same.
Yeah. It's a little bit easier. It saves you a little bit of time if you understand it. Yes.
What do you say, like,
You're at.
Well, you'd have to plug it back in here. So if you plug in 0, you get -2. So relative minimum of -2 at x equals 0. But for this, they just asked you where it happens, not what it is. So here, okay, so -2, which would give you -12 plus 6, which is -6. So that's, yes, so that's concave down, which means this is a maximum. And if they ask you for the whole point, you'd plug back into the original, not into this one. Plug x equals 2 back into the original, or x equals 0 back into it. If they ask for the point where it occurs, or the value of the function when it occurs. Okay, let me give you a homework. Okay.
No, not that one.
Let's do
Come on, we get
13, 15, 17. All right, wait. Those are the hard ones. The rest aren't hard. All right, 21 through, actually we did 21. Let's do 22 through 24. Those are just look at the graphs and tell the positives and negatives, okay? No, shut your mouth. No, we haven't even got, we got to spend another day on this Monday.
Oh yeah, we do.
We're not even to multiple choice yet. That is 9 problems, and 3 of them are look at the graph. Come on.
One of them.
There's y. All right, first derivative through the first times the second. plus the first times. When I worked it out on paper, I got it the very first time. It was just, must be something dumb I was doing. Times, and then I chain it. So I got, and I did go ahead and make common denominators in the beginning instead of waiting till the end. So that might have made a difference. Okay, let's keep going. I got a negative in here, so I'm going to make this minus. 2x times x is 2x squared over x squared plus 1 squared. I gave this an x squared plus 1, x squared plus 1, and just cleaned up my first derivative a little bit. X squared plus 1 minus 2x squared over x squared plus 1 squared. This is the same thing we got the first time we worked it. Yeah. So, again, I rewrote it like this. So that I could take the second. Here's where we started losing it. All right, derivative of the first one is 2x times the second one plus the first one times the derivative of the second. So that would be negative 2 times x squared plus 1 to the negative 3, and then I have to chain it. So I get 2x over x squared plus 1 squared plus, I've got, this is up top, and this is up top. So negative 4x times x squared plus 1 over x squared plus 1 to the third. Right? Yes. So for these to be common denominators, this needs another x squared plus 1. So this becomes 2x times x squared plus 1. This one stays the same. I'm going to go ahead and distribute this. Minus 4x cubed minus 4x. Everybody goes over the common denominator. Two x to the third plus 2x minus 4x cubed minus 4x. I don't know why I stumbled over this one so much the third person. Okay, then you're right so far. That's negative 2x cubed. This is negative. So this is negative. This is negative. This is negative. This is negative. There you go. So this is,
Because I don't think I've got this in the right.
no, I have it right here. Plus negative, negative. Whenever I carried that over, this was negative. There we go. which is 2x cubed minus 6x. That's what I was doing the whole time, and I was just fixing to do it again. There's a negative in front of that x squared right there. So it carries over to here, and it carries over to here as well. Take out a 2x, it leaves me with x squared minus 3. There's just so many places to mess up whenever you have a problem that long.
That just doesn't make ours the exact same thing. Plug in that. I do right.